Hi gang, welcome back. This is part 2 of the video for the Egg Pet UI. Hopefully you've watched the previous video where we made this layout for the UI. And this UI is going to pop up when we walk over and hit or get close to our eggs. So the principle behind this is when we created this UI inside of the screen GUI and starter GUI, the frame has a visibility marker, and if you turn that visibility marker on and off, it does exactly what you want, right? It's going to pop up and display it to the user. So that's what we want to achieve here. So the idea is, for our first part of the scripting, is we're going to get that visible to turn on and off. Well, how are we going to do that? Well, the way that is probably best and that I've seen most use is like you're going to measure the distance between your player and the egg, and when you reach a critical threshold, you turn the visibility on and you can interact with the menu. So let's get to it. So this we're gonna create a script that's gonna run. It's gonna be a local script because it's a GUI, and so this local script, we're gonna call that visible, because that's what it's doing. Is we're going to see if we are going to turn on and off visible. So this script isn't actually all that complicated. The first thing we're going to need is, since we're going to measure the distance between the player and the egg, we're going to need the local player. We won't need the egg right off the bat, because the script is going to query which egg you're closest to. So for right now, let's just create player. So local player equals game.players.local player. And so we're going to need a function that does that calculates the closest egg, right? So let's do a function closest egg. And we're going to send that eggs, but we're not going to do anything with this yet, other than, I guess we can, right now we're going to have like a local closest, right? Because there's a possibility that there is no egg this closest, so we're going to set this to nil, and then we can check on return to see if nil exists. Or it is nil, and then act accordingly. And so we're going to have some code in there, and then we're going to return closest. And so right now this is just going to return nil, but oh, my little error is just not initialized yet. That's fine. So now let's calculate the distance between us and something. So we're going to need to create a function, and we're going to create that function on every rendered step. And so step isn't the step is the step in the game, not your character stepping, but like think of it as a frame rate. So this is going to be a game get service run service, and then on a render stepped, we're going to connect, and we're going to connect a function. So what is this function going to do? Well, first thing we want to do is we're going to do some safety checks. We're going to check if the player is a player and alive, since this is just a safety check, so we're going to go ahead and do that. So if player dot character find first child humanoid so that checks to see if a player is a player and contains a humanoid part and player dot character dot health is not equal to 0 then. So the way evaluations work is if you just check player character health and player was not a humanoid, didn't contain health, then you could have something break right there. So the way evaluations work with an AND statement is that the first part of the AND statement is checked before the second part, and if it fails, the second part's never checked. So generally in most languages you can write AND statements that way, and the order might actually matter. So that's what we're doing here. And so inside of here we're going to look for the eggs in the game. So let's just call that local egg list, and we're going to set that to empty to start. And then we're going to need a magnitude for position. So we're going to do local pause mag equals current camera, and we're going to need to define that. C frame dot position minus current camera dot focus dot position dot magnitude. I'm going to divide that by 11. So what is current camera? Well, current camera is it exists in workspace, and we could probably just do workspace current camera, but we'll just create a variable for that. So local current camera equals workspace dot current camera, and so that will give us our position magnitude. And the next thing we want to do is we're going to go ahead and turn off by default our UI. So this script exists inside of our UI, so it's going to be script.parent.visible. So notice the script is inside a frame and its parent is visible is inside a frame, so its parent is frame, and we're going to just turn that off. So we're just going to set that to false, and this will be our default state, right? The UI is not on. And then let's look for eggs and what eggs are available in the game. So we're going to do this in a for loop and just iterate through everything, every egg in the game. So for iterator and egg in pairs, game dot workspace dot eggs get children do. So if you go over into the game inside of workspace, we are going to populate this with eggs. So we can see that we have this side in base plate right now. That actually probably needs to be scoot that up into workspace. So inside of workspace we have eggs. So game.workspace.eggs get children do. So this will iterate everything inside of eggs, right? And so previously in the previous video we have egg and other egg, and so this is going to iterate through both of those. And you can just add eggs as necessary this way inside of eggs, and it will iterate through all of them. We're going to later on do a little bit of configuration of those eggs that will need to match, but this minimizes the amount of changes in interdependency by just iterating through this. So we're not searching for specific names, we're simply iterating through that folder. So inside of there, we're going to do if egg.ui anchor. Now this is an independent interdependency. We require that eggs have a UI anchor, and we're going to find that. So if you guys are doing your own eggs, or you're buying stuff from your designers and your modelers in Blender, and they're creating the meshes for you, it's going to be your responsibility to let them know that they need to put a UI anchor in there, or you need to put it in yourself. And it doesn't need to be anything fancy. It's a part in the middle of that can't be seen. It's in the middle of your model. So and this just allows us to get a position. So if eggs UI anchors position minus players position, so wait for child, we're going to make sure that we're going to do wait for child so that it's all loaded, and we're going to do humanoid root part. Every player has a humanoid root part, and we're going to grab its position, and then we want that its magnitude to be less than 10 then. So if we're less than 10 away, we're going to insert an egg into the list. So it is very possible, and in a lot of games you'll see this, is you'll have many eggs that are sitting right next to each other. And you might want to display all of those, or you might want to just display one. We're going to display one in this video, so but it could be done both ways. So we're just going to create everything that's within 10 studs of our player. So we're just going to insert those into a list. So table.insert egg list, and then we're just going to put the egg name in there. And that's it. So now after we do that, we'll come out with a list of eggs. So if we find that we are close to eggs, then we're going to evaluate the list. So first, let's see if there's anything in the list. So if egg list is greater than 0, then, so if it's greater than 0, it contains something. So we're going to work on that list. So local working egg equals closest egg, and we're going to send that the list. So this will give us a working egg that is closest out of the one or many eggs that came from our table insert above. And so now we're going to get a world to screen point so that we can display our UI. So we're going to have local, and let's just call this w2sp equals game.workspace.current camera, and this we're going to call world to screen point, and the argument for that is going to be working egg dot UI anchor. It's not spelled right. Anchor dot position. So now we have our world to screen point that is the current camera. I guess we could have used our current camera variable, but our current camera and in relation to our UI anchor. And so if this is true, we have a closest egg. Well, we need to turn on our menu. So this is going to be script.parent.visible, just like before, and we're going to set that to true. And then script dot parent dot position is going to be equal to a udim 2.new, and we're going to have that 0. Our world to screen point variable in the X position. And then our 0 and our world to screen point in the Y position. We're going to set that. So what this will do is it will pop up your screen in position that is relative to your UI anchor from your closest egg. Then we're going to set current egg in our, well, we might need to actually add a variable. So what we would like is our screen GUI to know what egg is being worked on. So we want something like script.parent. So script.parent is our working egg, and then let's do a current egg value. Well, that doesn't exist yet, but we're going to set that to working egg name. And basically what we want in our GUI is our GUI just to be aware and track of what the current egg is. So that current egg can just be a screen value, and that is going to sit inside a frame because that's what we said it would be right here. So let's go ahead and add a string value that just tracks what the current egg is, and let's just set that to nothing at the moment. We want this to be current egg, and we want value to be nothing. Make sure that's nothing. So we'll set that value to the working egg name, and now your GUI can track on what egg it is using. We will use that to when we populate the script to find out what egg we're actually populating. And so now we've dropped out of the egg list, and we are going to set the screen size, or the GUI size. So script.parent.size equals udim2.new, and inside of this we're going to save size.x.scale. Well, what is save size.x? So we basically want to find out what the current size is before we enter this. So we're going to have local save size equals script.parent.size. So inside of here we're going to set this to pause mag, which we created earlier. Save size dot x dot offset. Save size dot y dot scale. Pause mag, and then save size dot y dot offset. All right, so that's our script, and hopefully let's go see if it's worked. Or can't see if it's worked yet because we actually have to do the closest egg. So it won't return anything right now because we have to do closest egg. So let's go ahead and finish that before we go in and run the game. So local magnitude equals 10. We probably should put this as a variable inside of screen GUI, but I'm just going to set it as hard-coded for the moment. So for egg name in pairs for eggs. So we sent it list. Actually, let's do we sent a list, so let's do it plural. And this shouldn't be not equals. We're setting it. And for egg name in pairs, do. And so inside of this for loop, we're going to create a local egg, and that equals workspace dot eggs, which is a folder inside of workspace, and we're find first child, and we want this egg name. So remember, we only set the egg name to begin with, and so we're just iterating through that list again. Instead of copying the whole egg object and sending it around, we're just iterate through the list again and find the one that we found before, and add it to the list. So this is going to be our local egg, and then our local magnitude is going to be equal to egg dot UI anchor dot position minus well, it's going to be basically what we did down here already. So it's going to be this. So let's just go ahead and copy that. Minus. So we just copied that. So egg.ui anchor.position minus player character, wait for child humanoid root part position, which is your character's position, and then take the magnitude. And so that will be our magnitude away. And now that we have our magnitude, we're going to evaluate if that's any better than the last magnitude. So if mag is less than or equal to magnitude, then, so remember we set that to 10, and we're probably going to put that in a variable later inside of our GUI, so it's easily configured. So closest equals egg. Spell that correctly would be nice. And then magnitude equals mag. So what is this doing? So as we iterate through this, the first time we go through, we get the first egg in the list, we calculate the magnitude from the player, and then we see if magnitude is less than or equal to magnitude, which is currently 10. If it is, then the closest egg equals the egg. And that is, remember, that's just the egg name. Or that's the actual egg, not the egg name. And then we set magnitude equal to mag. So this makes magnitude smaller than it was or equal, smaller or equal to what it was in it. And then every time it goes through this loop, if it finds something smaller, it sets the magnitude to a smaller value as it goes through the loop. And in the end, you'll end up with the closest egg. And so in the end, we return closest, which is the closest egg. So now let's see if that works. Well, got an error. Pause mag on line 44 visible. So let's go see what went wrong. It looks like I messed up some parens here. Let's see. Actually forgot the divide sign right there. Well, it's not so good yet. One, I think we forgot to turn off visibility. So let's go to frame and make this invisible and play it. Oh, still not working as we come close to egg. So what is going on here? Well, let's go through and debug it. So since this is pretty simple script, who knows where everything is? We look in here, there's nothing that's popping out, nothing came up in errors. So it's likely that we just simply missed something or have something weird going on. So let's find a way to just step through this. Since it's so simple, let's basically go inside of here and say, well, we're gonna print to output. Are we in here? So let's see, in for loop, and let's go to see if we make it in here, which is found player. And then let's go to see if we find it in here, which is render service. So, or render step. So let's see if we make it inside of here. If this is being called, then this will print. If this is being called, this will print. It's going to print a lot because it's going to print every frame. But let's see what we're doing. So we can see renders playing, but we're not seeing player. So we're not making into player, and player shouldn't depend on egg yet. So let's stop this and go see why we are not making it into player. So we can get rid of render. Hopefully all this works now because we're going to see why we're not in player. If player.character find first child humanoid and player.character.health. So this is all correct. And right there, humanoid misspelling. So let's go through and try it now. So get children is not a valid member of folder workspace egg. So it's yet another misspelling. So let's stop that and see it's right there. So we flubbed that, and let's go in and check it now. And hey, look, if we go to our other egg, we're getting it. Notice that the menu kind of surrounds wherever the egg is. That's because we set the position to UI anchor. So that's working. Let's move on to populating that thing. So in order to populate that, we're going to have a separate script. Let's go ahead and add that. It's going to be a local script. And let's call this local script pet view, because this is going to set up the viewer for what populates inside of this UI menu. This one is actually also not super complicated. It's a little bit bigger, but we're going to have to do some other little work to make it display right. And we're also going to have to probably add some stuff in Explorer. So let's go ahead and our pets are going to be eventually in replicated storage. I don't think we put those there yet, but we're going to have to do that. Because we're not going to have our pets just floating around in the game, right? We're going to produce them when we need them. So let's do a replicated storage. So local rs replicated storage is equal to game.replicated storage. We'll need the current egg again. So local current egg is equal to script dot parent, which is frame there, current egg, and we added that in the last script, right? So because we thought that we might need to do that. So current egg will just be populated by visible, and now we can just use it. Even better, we'll be able to evaluate when current egg changes, so that we can actually execute stuff inside of the script. So this is probably just for show right now, but I'll go ahead and show you how to do this. So for games that have money that's going to climb very high, instead of printing out a very large string of numbers for that, you might want to be able to just say like 1 million or 1 billion or 1 trillion, or there's games that have stuff that most people didn't learn. I had 20 years of college and didn't learn a lot of these things because there's just use exponents when they get that big. But anyway, so we're going to do a order of magnitude. This is not magnitude as we used it before. This is like an order of magnitude as far as numbers, and it's just going to be a list. First one is nothing. We have less than 1,000. The next one is K for 1,000. Next one is M for 1,000,000, and you get the idea, right? So we'll do billion, trillion, and you can do these as large as you want. Let's just do quadrillion, right? And you can just keep going up, do your own, and if you're gonna have some game with some ridiculously large number, you can just keep going up. Then we're going to get the frame, which is just our parent, so that we can use it. So local pets frame, and that's equal to script dot parents parent dot pets frame, because we're going to populate this thing. And let's go ahead while we're here and just grab the parent, and we'll just call that full frame. Oh, script up parent, sorry. All right. Let's go on, and since we already have our order of magnitude, I'm going to create a function right now, basically that makes easy numbers. So, and we'll actually just call that easy num. And easy num is going to take a real number and return a string that is more human readable. So let's make this local. You might actually want to put this in a module later, but we'll keep it local for now. So for I equals 1, and we're going to parse the number of entries in order of magnitude, and do. So if to number num, that way we make sure this is a number, is less than 10, but it's not just less than 10, we want actually orders of magnitude in orders of 3 actually. So to the power of I multiplied by 3. So then what this will do is it will iterate through in 3 orders of magnitude increments, and thus you'll get the nothing, the K, the M, the B, the T, the Q in 3 orders of magnitude increments. And so we'll just return that to math.floor. So the load, we're just truncating it out, and this is num divided by this, which is 10 to the power of I minus 1, because we've iterated too far so far, so we need to back up 1, times 3 divided by 100, and then divided by 100, and then dot dot order of mag I. So basically what this will do is we'll truncate out your number and then add the letter afterwards to let your player know a readable number on how much money they actually need for this egg. So that's all that does. Not really important for the video, or at least the menu, but it might be important for, I guess, the video. So now what we're going to do is, remember, we have current egg. Well, one of the things that Roblox offers is the ability to look to see if a value is changed inside of any object over in Explorer that you can see in Explorer. So what we're going to do is to say, hey, if this value changes, we want to do something. So current egg, and get property change signal. So something changed in current egg, and what we want to look to see is if current egg's value is changed. And if its value is changed, we want to connect to it a function. So every time the value is changed for current egg, we're going to do something. And what we're going to do is first see, did it change to nothing? We moved too far away, so it is now nothing. So first thing we want to do is if change is to no egg, then, well, we're going to do nothing. So if current egg dot value equates to none, then we're going to clear pets frame. We haven't created this function yet, but we're going to do that, and then we're going to return. So what do we want to do in clear pet frame? Well, we want to make sure that the menu is empty and ready for population. We don't want any leftover stuff in the menu, because you imagine if you went to a menu that had 6 pets and then which is the slots that we have, and you go to a menu that has 3 pets, those 3 might be left over, so we need to blank them out. And we also need to just make sure that we're working on a clear field, and since we're going to populate these with actual clones, we definitely need to do some cleanup for these clones. So let's do that. So we're gonna have a function. It's gonna be clear pets frame, and what are we gonna do in here? Well, we're gonna create another for loop for I frame, which is for each frame in I pairs, and then for what we're going to iterate through is pets frame, which is this right here. Pets frame, we're going to iterate through this, which will give us all these slots plus shadow. So pets frame, get children. Do. And the first thing we want to see is, hey, make sure this thing is not shadow, because we're not going to do that. So if frame dot name is not equal to shadow, then, so if it's not shadow, it has to be a slot. So we're going to for X in frame content in I pairs frame dot pet view port frame get children do. All right. So actually we have viewport frame, so it's not pet viewpoint frame, we're just going to do viewpoint frame. Alright, so basically it will look for anything that's been populated in here. So we didn't build anything in there yet. What we're going to do is populate that down in group property change with pets that are displayed in that, and so we're going to have to remove anything that's inside of there so that we're cleared up for the next time. So we're just going to do frame content, and we're going to destroy it. And then after we destroy it, we want to set everything else to nothing, and so we're going to do frame dot percent, which I think is what we named it, yes, is going to be equal to nothing, and frame dot rarity, then that's percent dot text. What's the value here? Dot text is equal to nothing, and frame dot image color 3 is equal to a color 3 dot from RGB, and we're going to set that to 0.115.172. We probably should just look in there, but let's just set that to that for right now, and that will clear that out.